everyone, today we are going to learn about one of the most powerful pillars of object-oriented programming, which is abstraction, and how it is implemented in Java using the abstract keyword. Abstraction is the process of hiding implementation details and showing only the functionality to the user. So abstraction is the process of hiding implementation details and showing only the functionality to the user. In other words, the user knows what something does, but not how it does it. Let me give you two real-life examples. Think about driving a car. When you drive, you use the steering wheel, the accelerator, and the brakes. You know exactly what they do, but do you know how the engine works internally? How the fuel combustion powers the wheels? Most people do not, and they do not need to. The complexity is hidden, only the functionality is exposed. Another great example is an ATM machine. You press withdraw, enter an amount, and money comes out. You know what it does. But you know or have any idea about the internal banking processes, the security checks, and the network communication happening behind the scenes? All of that is hidden from you, right? This is abstraction. Hide the complexity, show only what the user needs. In Java, abstraction is achieved through abstract classes and interfaces. Today we focus on abstract classes. Before we talk about these abstract classes, let's understand abstract methods. An abstract method is a method that is declared, just declared, but not defined. It has no body, no implementation, just a declaration. Here is how a regular method looks like. We have a class named shape, and a regular method looks something like this: drive. And if we want to print something, driving the car. And here is an abstract method. If you want to write, let me just comment this one. If you want to write or declare an abstract method, it is like this: public, abstract keyword, return type void, the name of the method, parentheses, and semicolon. This is the abstract method. Let me write it above of this method: abstract method. The abstract keyword is added before the return type. The return type is void, and before that is abstract keyword. And instead of curly braces with a body, it is just ends with a semicolon. Look, the difference between a normal or regular method and an abstract method. We have the access modifier. After access modifier, we have the keyword abstract, then the return type void, name of the method, parentheses, and instead of the curly braces and body, we have semicolon. An abstract method is essentially saying, this method must exist, but I'm not going to define how it works here. Each subclass or child class will define its own implementation. So, no abstract methods cannot exist in regular classes. An abstract method cannot exist in a regular class. So, an abstract class can only exist in abstract class. An abstract method can only exist in an abstract class. An abstract class is created by adding the abstract keyword before the class keyword. Before the class keyword here, we should add the abstract keyword. Look, here we have an error because the abstract method cannot exist in a regular in a regular class. So we should add the keyword abstract before the class name, before the class keyword, and then we see the error is disappeared. So let me now Now just write another regular method. For here, public void display. This is a regular method and it has implementation here. I want this method print for me. This is a shape, right? And I delete these two ones. I also have another, like I write an abstract method here. I write public abstract keyword, return type, the name of the method, area, and semicolon. This is abstract method, no implementation. I just declare an abstract method. Here are the key rules about abstract classes. Let's talk about each one. Rule number one, you cannot create an object of an abstract class. Cannot create an object of an abstract class. For example, you cannot write something like shape is equal new shape. This one will give you an error. If you really want to see, let me just go deeper and show you. Look, we have an error here, so it cannot be implemented here. And this makes perfect sense because an abstract class is incomplete. It has methods with no implementation, so creating an object from it would be meaningless. And rule number 2, if a class extends an abstract class, it must implement all abstract methods. Must implement all abstract methods or be declared abstract itself. So, rule number 2, if a class extends an abstract class, it must implement all abstract methods. Rule number 3, an abstract class can have both abstract and non-abstract method. Both abstract and non-abstract methods. It can have both. And rule number 4, an abstract class does not need to have abstract methods. A class can be abstract even with no abstract methods, just to prevent object creation. It does not need to have abstract methods. Let's talk about concrete class. A concrete class is simply any class that is not abstract. So you can create objects of a concrete class, and if it extends an abstract class, it must provide implementations for all abstract methods. Rule number 2. So let's see everything in action with a complete example. We have already an abstract class named shape. We have two methods, area, declare it as an abstract method, and a regular method named display, which is doing an implementation which is going to print this is a shape, right? Now let's create another class named circle. Circle. In class circle, we have a variable radius, declare it. We have a regular method, public circle, and we have a parameter here, double radius, and we want this method. I think I have a spelling error here, yeah. So we also want to, this class extends class shape. But look, we have an error here, because if a class extends an abstract class, it should implement all its abstract methods. Must implement all abstract methods. So which one is here? We have an abstract method in a shape class, and this one is public abstract void area. Let's implement or define it here. Public void, no need to write the name of the abstract keyword. The name of the method was area, and curly braces. Here we define the implementation. So we say we want to be written area of circle, and concatenation 3.14 multiply by radius, right? Okay, now let's create the object and then test it. How we can create the object? Circle T equal new keyword. Okay, I think to create an object, it's better just to copy the name of the class to avoid any misspelling. C new, the name of the class, parentheses, and semicolon. Inside parentheses, because we have a parameter here, we should add value. I add, for example, 7, and then C dot, now we call our method area. And we can also call display. So the method that we had in shape. So now let me run the program. Yeah, area of circle is 153.86. This is a shape. So look what happened here. Circle extended abstract shape class, right? And provided its own specific implementation of the area method here. Look, it has written its own implementation for the area. And display method was not abstract, so both classes inherited it directly from shape without needing to override it. And shape itself, the abstract class, has no object. It is just a template that defines what subclasses must do without defining how they do. So this is abstract keyword in Java. If you enjoyed watching this video, make sure to like and subscribe the channel so you never miss a video. See you in the next one.